Hey guys, Kyle here, classfordespairs.com, and we have a new machining video. In today's video, we're going to be making a plug that fits on the end of your inlet or exhaust camshaft for a matchless motorcycle. So if you guys are interested in learning and making something new, I highly recommend that you follow along on this video. In my left hand is the original plug. In my right hand is a tool that I made. The tool that I made features 4 1/8" pins. This will allow you to screw and install and also remove the original plug. The original plug was chrome plated, but chrome plating is far too expensive these days. So we're going to use 304 stainless so we can give it a really nice polish. So this is what we have at hand. Let's get to work. This drawing here features diameters, length, and thread pitch, and it will help us along the way to remanufacture this part. First things first, we need to remove the Atlas 5C collet chuck from the spindle. Then we're going to replace it with our trusty 3-jaw scroll chuck. Make sure we tighten it all the way around so we have good pressure and it's properly indexed. Once we have it in place, we are ready to do some machining. And we are off doing some basic machine work. There are 2 dimensions that we need to focus on while we're turning the OD. The first OD is going to be the OD preparation for the threads that we will cut, and the second will be for the larger portion, which would be the head for the plug. After we get that machine work done, we're going to follow up by cutting the threads. We're going to be using a Kinemetal tool with a 60-degree insert. Again, it's going to be 20 threads per inch. After doing our scratch pass, we're going to use our thread pitch gauge just to verify that we have a true 20 threads per inch. After we have verified that, we're going to use a 3/4 drill bit to drill and bore the end of the plug just like the original one, retaining the same depth. Now that all the external dimensions have been met, we're going to use our parting blade and remove the workpiece from the round stock. I've been doing machine work for about 5 or 6 years now, and this is the first time that I've worked with stainless steel, so I had to experiment with different RPMs and feeds to make sure we get a clean cut. With the workpiece cut off, we have it back in the 3-jaw chuck so we can focus on the face so we can get a better finish, and we can also get the proper thickness that we need. We're using a CNMG and it's leaving a really beautiful finish. Followed up by that, we're going to use a micro 100 radius cutter, and it has seen better days, so we can get a nice radius on the end. Alright, so all the external machine work has been done, or at least what we can do in the lathe. So this is what we have there. So on the right hand we have the original piece, and on the left hand we have the new piece. Really nice finish, everything's looking good. So now we got to get our rotary table set up so we can start drilling holes. With the plug in the 3-jaw chuck, we're going to use our Mitutoyo indicator, and we're going to sweep all the way around and use the part to be able to center the entire rotary table. Now that we have the part ready to go and our rotary table zeroed out, we're going to feed in the x-axis. Since there will be a total of 4 holes, that means we need to drill a hole every 90 degrees. I'm going to be using a 1/8 inch carbide end mill. Got a little bit of oil there on the side so we can make sure that it's cutting fine all the way around. As far as the depth goes, we're going about 150 thousandths deep, and I'm using the adjuster on the quill to make sure that we get the depth all the way around. Here I am just wiping some chips off, basically setting that first hole so we can get the proper depth so we can set it up for the rest of the 3. Now you might ask yourself, why am I using an 1/8 inch end mill rather than a drill bit? The end mill itself is more rigid, and considering how tight tolerance the tool is, I need to make sure that each hole is going to be straight. If I use a drill bit, there is a chance that the hole could be enlarged, and there's also a chance that the drill bit can walk. So with this way, we can ensure that we get all 4 holes in the exact position that they need to be in. Now that we bored all 4 holes, we're going to use our tool just to make sure everything lines up. So everything comes down to this point and it looks good. Since my job doing the machine work was complete, I went ahead and passed it over to my dad so he can start doing some polishing. He's using a Scotch-Brite wheel, I believe, to remove some of the tool marks on the part, which were a few, and then he followed it up by actually polishing. So it looks really good. He's very happy with it, but I think he's going to spend some more time to get even a better finish. And there you have it. We have the original part on the left and the new part on the right that we just finished. As you can see, it has a really nice finish that my dad polished it. So everything is looking really good. My dad is really pleased, which is the most important part. The tool fits, it threads in the case, so we are good to go. If you guys enjoyed this video, don't forget to like, share, and subscribe. Check out our website, classicbritish spares.com, and also check us out on Instagram. I appreciate you guys watching. You guys have a great day.